because when things are exponents, you can work with them. When things are in their radical form, they're a little bit harder to work with. So in the first one, what should I be doing first? What should I be converting?
For number, are we doing number 1 or number 2?
Number 1.
Oh, okay.
Yeah. So what is something that I can do given, look, remember what I just said, we want things to be exponents rather than radicals. What should I do first?
Well, what I did is that I just like broke apart everything instead of like just
Mhm.
one how do you one part of the equation.
It's an expression because it's not an equation because there's no equal sign. So it's just an expression. So all we're really trying to do is, like Ijara, like you said, we want to break it down until we can get it in its simplest form. So what is something that I can do?
You could break down both of the expressions or the whole expression to 4 by the power of 4. Well, we're gonna distribute the left side.
Okay. Yeah. So that's one thing we can definitely start out by doing is we have this exponent on the outside, and we know when you have parentheses with an exponent, we're definitely going to want to distribute that exponent. So let's do that first. So I get 4 squared times x to the power of what?
Oh, I
Of
messed
8.
up. But I
Uh-oh.
still the same answer at the end.
Okay, let's see what you did wrong, and then let's see how we get it to be right. So yeah, so we got x to the power of 8 because we got to multiply those exponents. So 4 times 2 is 8. Okay,
Why didn't you multiply 2 by 4?
because it's not a coefficient. I'm not multiplying 4 times 2. I'm bringing it to the second power. That's an exponent. That 2 is an exponent. So when you distribute it, you have to keep it as an exponent. Does that make sense?
Yeah.
Okay.
I
Okay.
wish it would have been smaller.
Oh, yeah, sometimes you got to be careful, but usually, like, let me just write this a different way. If this had been a coefficient, if it had been a whole number, usually where does that go? Does that go on this side or does that go on that side?
That side right there.
Or the front side.
On the front, right? So if it was here, that would be a little bit weird. So I know it was a little bit large, but it is, you can kind of tell it's smaller than the 4, right? It's a little smaller than the number 4. So you can sort of tell it's an exponent. Okay, so I've got this so far. Then I have this situation. So I have the cube root of x to the power of 9. So what can I do with that?
X by the power of 9 over 3.
Good. So remember, the number that's on the ledge on the little balcony, that goes down into the denominator of the fraction. So this is 9 over 3. So that's how we got to switch back and forth, back and forth. That's something that by now should feel a lot more comfortable, how to turn it into an exponent. Well, what happens? What is 9 over 3?
3.
That's just 3. So let me simplify that. So now I have 4 squared, times x to the power of 8 times x to the power of 3. Okay, things are looking a lot simpler, aren't they? Now I can start kind of putting things together. 4 to the power of 2 is what?
8.
Oh, careful, not 8.
16.
Oh, 16.
16.
16, there you go. Remember, it's 4 squared, 4 times 4. And then what can I do between these two numbers? These two exponents.
You can add them.
Good, we are adding the exponents. So that's x to the power of 11, giving us C. Now be careful, because how do you get answer choice D? What did that person do by accident?
They multiplied the exponent.
They multiplied the exponent. So just be careful, because look at what's happening. We have 2 different values that are being multiplied together. We have 2 base numbers that are being multiplied. That's different from something like this. in that case, because of the parentheses, this only works when you have parentheses. We're distributing the exponent, and that's when you multiply. So just go ahead.
What happened to the 9?
Which 9? On the exponent? The pink one?
Yeah.
We divided it.
9 divided by 3 equals 3.
Oh, okay. I was a little confused.
No worries. Yeah, that's where we got 3 from. Any other questions?
I know where I did wrong. For some reason, for the second, for the second step,
Mm-hmm.
I put 4 by the power of 4, and then it gave me 256.
Uh-oh.
And then at the end, I didn't 256 for the answer. So I'm like, what if I do 256 by the power? Squared, and then I got the answer for.
Okay, so yeah, sometimes when you get something that's completely off, you got to go back to the beginning and see where you might have gone wrong. Okay, I want to just explain something that came up in the chat. So we have two different words that come up a lot, right? That is radical and then rational. And they're very similar. So I just want to clarify the difference. A radical is this symbol right here. So when I see that symbol, I say, oh, that's a radical. Or maybe I'll say, oh, we have a radical expression. We have a radical, we want to turn it into an exponent. So you'll hear me saying it like that. That is a radical. Rational is a type of number. So remember, a rational number is any number that can be written as what?
A fraction.
Good. Any number that you can write as a fraction. So I know that they're very similar words, but they're just completely different things. So just make sure that you don't get those two confused. Even I say them, I just now said the wrong word, so just keep that in mind. Okay, so one more time. Why did I get 11 and not 24?
Because for this, it's one of the rules. I forgot the number, but on one of the rules it said we have to add when there's multiplication on bases instead of, and then if there's parentheses and there's a power, that means we're gonna have to multiply.
Okay, good. So here's a different, this is what I was showing you before. If it looks like this, then yeah, that's going to be x to the power of 24, because that's when you multiply. That only happens when you have parentheses. So when you do have parentheses, we're multiplying. But in our case, it was not parentheses. We're just multiplying two x's together. Okay, so that's the difference. And I can also show you, let me show you one more thing. The reason we're adding, because it might seem a little weird, like, why am I adding this? Well, that's because, what am I really doing? I'm doing x to the power of 8. So that's x times 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 x. That's 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm doing x to the power of 8 times x to the power of 3. So 1, 2, 3. So how many x's am I multiplying altogether?
11.
11. So that's why I end up with x to the power of 11. So that's just to review why we are adding those two numbers. That is why, because that's how many we've got, 11 in total. All right, so any other final questions on number 1? Cool. All right, now let's take a look at number 2. Well, number 2, we already have everything in using exponents, but even though we have exponents all together, the bases don't match. So we can't really do anything with this the way that it's currently written because the bases don't really match. So there's 2 ways that we can go about this. Can anyone give me, if you got the answer right, or if you feel like you know, can anyone give me a suggestion for what I could do?
Turn the whole exponent
Expression.
expression, sorry. It's
You're
just
good.
kidding. Expression into radicals.
Okay, so let's see what happens when I do that. So 27. So here's my radical. What number goes inside? Which number goes outside?
2 goes
Two
inside,
inside.
2 goes inside,
3 goes out.
3 goes out. Now on the bottom,
Just 9 squared.
the square root of 9. Make sure you say, because 9 squared would be an exponent. So just
Oh,
like
sorry.
the square root of 9. No, you're good. Good, because 1/2, that would mean that the 2 goes outside and the 1 goes inside. But we don't need to write that 2, and we also don't need to write that 1. So I can just leave it as the square root of 9. Okay, well, we can do a little bit of math here. Remember that whenever, like in the numerator, there's 2 separate things happening. I have an exponent of 2, but I also have the cube root. And you can do one first and then the other. So you can either, I can do the cube root of 27 and then take that answer to the power of 2, or I can do 27 squared and then take the cube root of that answer. You can go one and then the other. Which one of these operations would be easier? Taking the cube root of 27 or putting 27 to the second power?
Cube root of 27.
Cube root of 27. So for that reason, let me see if I can move this guy. Come on. He does not want to go. There we go. I'm just going to move this guy out, and I'm putting parentheses around the cube root of 27 just because that's what I'm going to do first. And the reason you can do that first is because that number should be on the back of your head somewhere. Like, you know that number. We know that the cube root of 27 is what?
3? I mean,
Is-
no.
Yeah, it's 3.
Oh, I'm sorry. I was thinking of something else.
The cube root of 27 equals 3. Because on the other hand, going backwards, 3 to the third power is 27. And remember, that's just the opposite. The cube root is the opposite of the third power. So I can rewrite this whole equation. Because in my numerator, I end up with 3 to the power of 2. And in my denominator, I end up with what? What's the square root of 9?
3.
Also 3. So I have 3 squared over 3. What's 3 squared?
9 over 3.
So I have 9 divided by 3, which gives me
3.
3. Giving me answer choice B. So this question is all about how can you rewrite things so that they are easier to understand. Because if you say to me, oh, 9 to the power of 1/2, that's kind of hard to understand. You can't really do the power of 1/2. But then when you rewrite it as a radical, oh, now I have the square root of 9. I can do that in my head. I can do the square root of 9. So it's a way to make things a little bit more simple.
And also, one thing I noticed is if you divide 27 by 9, it will give you 3, but at the same time, what will happen to the fractions?
Right. So that's something that actually somebody just said in the chat as well. You can't really do that. You can't really do that because let me explain why. Let me give an easier example. Let's say you had 4 squared over 2 squared. Okay, what is 4 squared?
16.
16. What's 2 squared?
4.
4. What's 16 divided by 4?
4.
4. Okay, so in my little example, the actual answer is 4. What if I just decided to divide the top and the bottom instead? 4 divided by 2
2.
is 2. Do I get the right answer?
No.
No. So you cannot divide things when they have an exponent with them because that exponent changes the value of the number. So if I decide, and you know what, that actually comes all back to our good friend PEMDAS. What does PEMDAS say you have to do before dividing?
Multiplication.
Even before that?
Exponent.
Exponent. You have to do the exponents first. So, okay, in our example, 27 divided by 9, okay, yes, you do get 3. So I'll give you that. It works out in that example. But that's not always going to work out. And so this is a good example of how it doesn't always work out. And that's because you have to deal with the exponents first. Any other questions on that? Cool. Okay, I'm going to show you guys one more way to do this problem because there is one other way. Remember when I said from the beginning that we have these exponents, but the base numbers don't match, right? I have a 27 and then I have a 9. So the base numbers don't match. But I'm going to rewrite them a different way because I know, because I remembered from what Miss Lopez taught me, I remember that 3 to the power of 3, what's that?
27.
27. And 3 to the power of 2 is
9.
9, right? So what I can do is I can actually rewrite these two values. I can write it as 3 to the power of 3 to the power of 2/3 and 3 to the power of 2 to the power of 1/2. So I kind of just rewrote the number 27. I wrote it as 3 to the power of 3. The number 9, I rewrote it as 3 to the power of 2. And now I have matching bases, which is actually going to help us out a lot. So what I can do now is a little bit of multiplication. I can do 2/3 times 3, and I can do 1/2 times 2. So what's 2/3 times 3? 2/3 times 3.
6 by 3. I mean, no, 6 over 3.
6 over 3. 6 divided by 3?
2.
Is 2. And then what's 1/2 times 2?
That equals 1.
That's 1. So now what I have is 3 squared over 3 to the power of 1. So we could have arrived at the same answer, same exact answer, just a different way to do it. Does anyone have any questions on how I did it this time around? Okay, cool. So this way is the way that I just did it. Sometimes is actually easier than trying to evaluate the answer. So I'll explain what that means. We're going to do a couple more examples this way, where you'll see why it's actually easier to do it this way. But what I want to do now, because it is Friday, and I promised you guys something a couple of weeks ago that we haven't done quite yet. And that is that because of all of your test scores, you've done the iReady, you've done the topic 6 assessment. I don't know if y'all remember this, but I did say that I was going to do an Uber Eats raffle. So we're going to do that right now. So let me go ahead and I'm going to show you share my screen. Okay. So what I did was I have 2 raffles going, and these raffles are going to be for $15 each on Uber Eats. So you can order yourself whatever you would like up to $15. And what I did was I split it up into most improved scores on both iReady and the topic 6 assessment, and then also the highest score on iReady and topic 6 assessment. So take a look. For most improvement, these are all from different periods. So for this period, it looks like I've got Karina, I have Sophie, I have Ejira, Raymond, Ejira again, Jade, Anaya, Jeffrey, Bianca. So all of you guys are in that raffle for most improvement. And then I also have a raffle for highest scores. So congratulations to Karina, Sophie, Juan. Who else we got? Ejira, Sophie again, Anaya, Karina again. And that's it for that. So congratulations to the highest scores as well as the most improved scores. And what I'm going to do now is we're going to pick a name from each of those lists. All right. So the more times you show up, the higher your chances. So some people are on here twice. You guys got entered into the raffle 2 times. So you have a slightly higher chance. So let's go ahead and see what we got. This list is for most improved. All ready? Should I do a little drum roll? Here we go. Oh. Ooh, that was really close. That was really, really close. I'm sorry, today. He like just got it by a tiny little bit. All right, so yeah, congratulations, Raymond, you are here. All right, now this one's gonna be for highest score. So here we go. And Sophie! Congratulations! Amazing. Okay, so you guys both are in this class. That's awesome. So I don't even have to do it during my 8th period today. So congratulations. Can you both just privately send me your address, the best phone number to reach you at, and then what you would like? And I will set that up for like after you get home today. Or actually, both of you are already home. So I'll let you know when we'll make it happen. So send me your address, the best phone number, and what you would like to order, just privately on Zoom. So congratulations, you two. Nice job. And everybody else, there will be plenty more opportunities to win these raffles later on. So you guys just keep doing the best that you're already doing. And as we keep going through the year, I'll set up more opportunities for that. All right, back to business. Here we go. So like I said, today we're reviewing radicals, we're reviewing exponents, as well as what we talked about yesterday, which is rational numbers and irrational numbers. So I'm bringing this back because we did it yesterday, but I definitely just want to review it because it might come back later today in a different way. Hint, hint. So let's just take a look. It's asking what is the value of x in the equation below? And basically what you want to do is work on the left side in order to simplify it as much as possible until you just have one number in the exponent. So there's a couple of things going on, right? I have the 4th root. I'm taking the 4th root of p over q. And then I'm also taking p over q to the 4 over 3 power. So I've got like a combination of radicals and exponents. And remember what I said, you always want to try to get things to be exponents, because once everything is in exponent form, you can multiply the exponents or maybe add the exponents or just do something to simplify those exponents. So in this case, what should I do first? What are some ideas? Anybody?
We did this before, but I've had like a huge brain fart on what we do.
That's okay. Remember what I said. I'll reiterate it. You want, when you have a mixture of radicals and exponents all in one problem, what do you want them to all turn into?
Fractions?
So exponents is you
Okay.
always want to turn everything. If you have a radical, you want to turn it into an exponent. Because things are, when they're in exponential form, it's a little bit easier to work with it. So in this case, what can I turn into an exponent?
4.
Which 4? You're correct, but which one?
4 on the bridge, balcony.
In the little balcony, right? So it's a little bit hard to, I can rewrite this to make it look a little bit more like what you're used to seeing. But what's happening here is we have P over Q, the fourth root of P over Q to the power of 4/3. So like Ajira said, what I can do is I can turn this radical into an exponent. So we want to turn it into an exponent. So in order to do that, what fraction exponent is it going to be?
4/1.
Okay, let's see. So I have P over Q. And remember the rule. The number that's out on the balcony ends up where? In the numerator or in the denominator?
Denominator.
Denominator. So that 4, that number 4 ends up in the denominator. But then what goes in the numerator?
1.
Good. Where does that 1 come from? And this goes for anybody. Where does that 1 come from? Because I know the 4 was on the outside of the radical. So where's that 1?
The 1 is supposed to be in the denominator, but since the 4 goes in the denominator, we had to switch it up.
No, the 1 should have always been in the numerator. It's just that I'm wondering, where did it come from? Because I don't see a 1 in the previous step.
Is it like an imaginary one?
That's what it is. Because remember, any number, if it doesn't have an exponent with it, so like this P over Q doesn't have an exponent on the inside, so invisible, we got an invisible 1 right here. Because remember the rule, the number on the inside goes up to the numerator, the number on the ledge on the little balcony goes to the denominator. So that's where the 1 comes from. So do I have any questions on how I turned that into an exponent?
Miss, can you repeat that?
Yes. Matter of fact, I'm going to erase this whole thing. I'm going to make it easier. So I'm going to, because I think a lot of you guys are confused by the P over Q. So I'm going to make this easier for you. Okay. Same problem, I just changed the P over Q to a letter M, just to make it a little easier to look at. So like we were saying before, M does not have an exponent with it on the inside of that radical, right? There's nothing in there. But whenever you have a number with no exponent, there's always an invisible 1. We just don't write it because we don't need to write it because it doesn't change the value of M. So there's the 1. Here's my 4. The fourth root of M to the power of 1, we can rewrite that as M to the power of 1/4. And that's just our rule. The number that was out on the ledge goes to the denominator. The number that's on the inside, the exponent of 1, goes up to the numerator. But I still have this 4/3 that has to come down. So I'm just going to bring that down. How do we feel about that? Does that kind of make a little more sense?
Yes.
Okay, any other questions up to this point? Okay, well now I have two exponents. I used to have a radical with an exponent. Radical and exponent, you can't really do math between those two. But two exponents, I can do the math. I can do what I know I gotta do. So this is now a distribution situation where what do I do between these two exponents? Do I add them, subtract them, multiply them? What do I do? 1/4 and 4/3.
Do you add them?
Not in this case. This is not an addition situation. What is this? There's parentheses, so that should give you a little hint.
Multiply.
Multiply them, yeah. So we're multiplying 1/4 times 4/3. What does that give me?
4/12.
4/12. And can I simplify 4/12?
1/3.
1/3. So I have m to the power of 1/3 equals m to the power of x. So that tells me that now that I have matching bases, everything is super simplified. Now I just know that x equals 1/3. Because that's what makes the equation true. So that's answer choice C. So again, I'm going to ask because hint, hint, you will see a question very much like this at the end of class today. Do I have any questions on how I got any of those numbers?
So if we ever see this problem at the end of the class and we see a fraction on the outside and then just a number on the balcony, that means we're gonna have to do this this process.
Yeah, exactly. So let's break down what we did. Step 1 was turn the radical into an exponent. What did we do in the second step between the two exponents? Oh yeah, multiply the exponents.
I mean distribute.
You're right, yep. Let me fix that. So distribute and multiply the exponents. And then the only thing I really had to do in the end was to simplify. And it's really just those two steps. The problem to begin with looks challenging, and that's only because we have a radical next to an exponent. But I know that by turning the radical into an exponent, after they're both exponents, you just use your exponent rules to multiply them, or maybe you might have to add them, or maybe you might have to subtract them. But it's a lot easier to do those operations when everything is in exponential form. Any final questions on this one? If you don't know where a number came from or how I did any part of it, let me know. Okay. All right. So I'm going to go ahead and, by the way, let's just remember what it looked like to begin with. The original problem looked even harder because the number inside the variable that we were working with was P over Q. But I just changed it to an M because an M is just easier to look at, right, than P over Q. Did it change any part of the problem? Did it change any part of the answer? Absolutely not. Okay, so sometimes if the variables look a little confusing, you can just turn it into any other letter you want, just to, if that makes it simpler to look at, you can do that. All right, so let's go ahead and check out another one. So if x represents a positive real number, which expression is equivalent to the cube root of x squared plus this, or times the square root of x to the power of 5? So remember what I said. These are in radical form. What should I turn them into?
Exponent.
Exponent form. So we're going to turn the radicals into exponents. So 3, or the cube root of x to the power of 2. What is my exponent in this one? Which number goes in the numerator? Which number goes in the denominator?
2/3.
2/3. 2/3. What about what's missing in the square root of x to the power of 5?
The denominator, but it's gonna be 2 because of square root.
Good. So remember, when there is no number on the balcony, there's a 2 there. It's just invisible. So we have a 2. So like Ajira said, that's the denominator. So we end up with x to the power of 5/2. Questions on that first step? Well, now what do I do between these two exponents? Should I be adding them, multiplying, subtracting? What should I do?
Add.
Add.
Good. In this case, we're going to add. So we're going to add the exponents. Well, okay, so I got to do 2/3 plus 5/2. How do you add fractions again?
Multiply the denominator to get the denominator from the other exponent.
Kind of. Well, in this case, we want the denominators to match. So which number can I get in order for them to match? What's going to be the common denominator?
6.
6, good. So we're going to get them over 6. So 2/3 becomes what?
2/3 becomes 4/6.
4/6. And 5/2 becomes
15.
15/6. Questions on how we got those numbers? Okay, so now we can add these up. 4 plus 15 gives me
19.
19/6. So I end up with x to the power of 19/6. Well, my answer choices are all in radical form, so now I gotta just switch it back to radical form. So turn the exponents back to radicals. So 19/6, which number goes out on the balcony?
6.
The 6 goes out here, and the 19 belongs inside. So we end up with answer choice D. Questions on this one? Any questions on how I got those answers, where those numbers came from, how to add the fractions, any part of it? Okay, adding the fractions. Let's review that real quick. So First of all, to add fractions, they have to have matching
Denominator.
denominators. You can't add fractions if they don't have matching denominators. So how did I get from 2/3 to 4/6?
How did you get pardon?
From 2/3 to 4/6. How do you turn that into 4/6?
You have to multiply their least common multiple, I believe. Or
Yeah, between 3 and 2. So we needed to get them to be both over 6 because that's the least common multiple between 3 and 2. So I multiplied 2/3 times 2/2. 2 times 2 is 4. 2 times 3 is 6. I get 4/6. Now with 5/2, what did I multiply it by?
we
Had it
multiplied it by 3.
by 3. 3/3. 5 times 3 is 15. 2 times 3 is 6. Now they have matching denominators. All I got to do is add the numerators. 4 plus 15 gave me 19. Adding fractions. Adding fractions. Any questions on that? All right. Any final questions on this problem? Cool. Let's do another. Now I want you guys to do this one on your own. Start off on your own. Take about 2 minutes. All right, couple seconds remaining. Ten seconds. 5, 4, 3, 2, and 1. All right. So I've got a radical. Clearly, I got to turn that radical into an exponent. So which number belongs in the numerator of my exponent?
52.
52 goes on top. Good. 52 goes on top. 13 goes in the denominator. And now I can simplify because what is 52 divided by 13?
4.
4.
It's 4. C is my answer. Okay, so with this type of problem, very, very simple if you just remember that rule. It should not take very long to turn that into an exponent and then simplify. Any questions on this one? If you did it backwards, if you had 13 over 52, notice 13 over 52 simplifies to 1 over 4, which would mean that you'd have two answer choices that are the same. Now, this does not say select all that apply, so would that make any sense if both answer choices were the same?
No.
It wouldn't make sense, right? So you can kind of tell that those are incorrect. All right, let's try another one. Okay, this one's a little, it looks complicated, I know, but let's just break it down. So Ned shows that the square root of 16 equals 16 to the power of 1/2. Part of his work is shown below. Which expression or equation can be placed in the blank to correctly complete Ned's work? So basically, don't stress too much about what he did, because at the end of the day, whatever goes in the blank has to be equal to 16 over to the power of 1/2. So just take a look at that part. So what we can do is we can look at the answer choices and figure out which one matches with 16 to the power of 1/2. So what I'm going to do is I'm going to go just straight down the answer choices, starting with the first one. 4 squared to the power of 1. 4 squared to the power of 1. What do I need to do between 2 and 1?
2 and 1. Distribute.
Distribute. Distribute and add, multiply, divide. What do I do?
Multiply.
Multiply. So 2 times 1 is just 2. Okay. Well, at this point, I don't have matching bases. So what is something that I can maybe do to make them match?
Do the by power by 4 by the power 2.
Yeah. What is 4 squared? We know what that is.
16.
That's 16. Well, 16 on its own has an exponent of 1. We know that. So do these match? Is 16 to the power of 1 the same as 16 to the power of 1/2?
No.
No.
No, right? They don't match. So A is out the window. Does that kind of add, do we understand what I'm doing here? I'm kind of just testing out each answer choice just to see which one actually makes sense. So A is out. Let's look at B. 4 to the power of 1/2 plus 4 to the power of 1/2. Okay. 4 to the power of 1/2. What would that be the same as? What's another way to write 4 to the power of 1/2?
4 4 square root.
The square root of 4. That is correct, because the 2 goes out on the balcony and the 1 goes inside, but the 2 and the 1, we do not need to write them. They are essentially invisible. So that's just the square root of 4. What is the square root of 4?
2.
It's 2. So 2 plus 2 equals 16 to the power of 1/2. Okay. So 2 plus 2 is
4.
2 plus 2 is 4. Okay, cool. And what about 16 to the power of 1/2? Can I rewrite that a different way? Can I rewrite that?
The square root of 16.
Right, same thing, right? Because 16 to the power of 1/2 is the same thing as if I put the 2 out on the balcony and the 1 on the inside. But like we just said, we don't need to write those two things. So it's the same thing as the square root of 16. Well, what is the square root of 16?
4.
4.
It's 4. So 4 equals 4. We got a match.
This is multiple choice or?
Yes, multiple choice. So at this point, I can basically circle, and that's all I got to do. So when it comes down to this type of question, you really just have to figure out how do you turn one side of that equation into the same thing as the other side? How do I kind of manipulate it by switching it using the rules that I know, because we know those rules. So how do I use those rules to force the two sides of the equation to look the same? That's what we're doing. So how do we feel? Any questions on that? Okay. All right. So now let's go ahead and review the operations with rational and irrational numbers. So we talked about this yesterday. I just quickly wanted to review what they are. So let's talk about addition. If I have a rational number plus a rational number, what do I always get?
Rational.
Always rational. Good. Always rational. If I have an irrational number plus an irrational number, what happens?
Sometimes rational.
Irrational.
Sometimes rational.
Sometimes. Specifically, what's the one exception? What do you sometimes end up getting?
0.
Good. Sometimes you end up with 0. All the other times it'll be irrational, but if you get 0, then it's rational. And then what if you mix them up?
Irrational.
Irrational.
Good. So it's always irrational. So basically, it's never going to be rational. So that's addition. Is it any different with multiplication?
No.
No, same exact pattern with multiplication. The only difference is that, let me just write it down. So a rational number times a rational number is always rational. An irrational number times an irrational number is sometimes rational. But in this case, there's actually multiple exceptions. With addition, irrational plus irrational, once in a while you get 0. That's the only instance in which you have a rational answer. Everything else will always be irrational. With multiplication, an irrational number times an irrational number, actually more often than, like it does happen more often that you'll end up with a rational answer, because you could end up with the square root of a perfect square. So there's more chances to get a rational number if you're multiplying compared to addition. But everything else, so when you mix them together, r times I will never be rational. So it's pretty much the same 3 rules, which is useful for memorization. So this is something definitely make sure you have memorized, because the questions that come up are actually pretty easy. This is a very simple question on a test that if you just have this memorized, you can definitely get the answer. So now let's take a look at a couple of questions. So this one's, I might actually leave this one for last. I want to do a couple of easier ones first. So somebody just remind me to come back to this problem. But let's start off with something a little bit simpler. So it's telling you that L is the square root of 2, M is 3 times the square root of 3, N is the square root of 16, and P is the square root of 9. So before we begin, let's just assign each one. Which of these is irrational and which of these is rational?
Irrational is M. Irrational is L. And the rest are rational.
Good. And how do we know that square root of 16 and the square root of 9 are in fact rational?
Because the square root of 16 is 4 and the square root of 9 is 3.
Good. So both of these are rational. Cool. So now we can kind of think about what's going to happen. L plus M. L plus M, that's going to be irrational plus irrational. And what do we know most often 99% of the time, what does that lead to?
Irrational.
Irrational 0.
Irrational. 99% of the time, that's going to be irrational. So in this case, we can check just to make sure we don't end up with 0. The square root of 2 plus 3 times, what is that? That's not a 3. 3 times the square root of 3. Well, I don't really know the answer to that, but is it going to be 0?
No.
No, because remember, the only way to get 0 out of something is if you add it and then take it right away. So when you add and subtract the same number. Well, in this case, I don't know the full answer, but I know that this is going to be an irrational number. So I'm looking for which of these is rational. It's not going to be A. Not going to be A. All right, what about B? M plus N. So that's going to be 3 times the square root of 3 plus 4. That's an irrational number plus a rational number, which always gives me what?
Irrational.
Irrational.
Irrational answer. So not going to be B either. How about N plus P? 4 plus 3.
Rational.
That's 7. So this is my rational number. That's the only one, because let's check out P and L. P plus L, that's going to be 3 plus the square root of 2. So that's rational and irrational, which will give me an irrational answer. So C is the only one that gives you a rational answer. And this is kind of what, for the majority, this is what these kinds of questions will look like. So they're going to give you examples of rational numbers and irrational numbers, and you have to know which one is irrational and which ones are rational. So does anybody have any remaining questions on what makes something irrational and what makes something rational? Okay, cool. Let's try another one. Go ahead and take a look. This is a very basic definition type of question. So again, this is the type of question that would be pretty easy on a test as long as you remember the rules. I'm going to put a poll up, so go ahead and pick the correct answer choice when you've got it.
What does it mean by non-zero?
That it's not 0. That's all it means.
Misclick.
What?
Misclick.
You clicked the wrong one?
Yeah.
Oops. You're that one person who put the wrong answer. No, I'm kidding.
Oh damn, you're
I'm
gonna call me
kidding.
out too.
I'm kidding. I'm kidding. You're not the only one. All right, take about 10 more seconds. 10 more seconds. And 5, 4, 3, 2, and 1. Okay. Let's take a look at what happened. So it looks like B was the most popular answer. And now let's just read them and check. Because again, this is very, if you remember those rules, this should not be very difficult. The only difficult thing is that we're looking for which one is not always true. So which one is false? Sum of two rational numbers is rational. Is this true or false?
True.
That's true, yeah. Rational plus rational is always rational. So there's no going wrong with that one. That's definitely true. How about B? The product of two irrational numbers is rational. What do we know about I times I?
It's gonna be sometimes rational, but not rational all the way.
Good. Sometimes it's rational. Well, this is telling me that it's always going to be rational. And we know that that's not always true. Sometimes it is. Sometimes it is, but sometimes it's not. So this one is the one that's not necessarily true. This is false. Now the rest, just to double check, the sum of a rational number and an irrational number is irrational. Is that true? Is that a true statement? Rational plus irrational. Will that ever be rational? So, because we wrote it down like this, we wrote down r plus I is never r. So if it's never rational, that means that it's always irrational. So that is true. That is a true statement. And then finally, the product of a non-zero rational number. So again, the reason it says non-zero is because we know that the product of anything times zero will just be zero. So by telling you that it's non-zero, that's just making sure that the answer doesn't end up being zero. But the product of a non-zero rational number, so rational times irrational, what's this one? Rational times irrational. Anybody?
Rational times irrational.
Mm-hmm.
It will never be rational.
Never rational. So since that's never rational, well, that just means that it's always irrational. So is irrational? That's true. That's always true. So the only one that is false, the only one that they're telling us it's rational, but that's only sometimes. Sometimes it's rational. It's not always going to be rational. So B is the one. So this is a couple people probably chose the wrong answer because they didn't read it carefully. Just make sure you're reading it carefully because you were looking for the one that is not always true. Okay, so any questions on this one? Okay. All right, Jacob is working on his math homework. He decides that the sum of the expression 1/3 plus 6 root 5 over 7 must be rational because it is a fraction. Is Jacob correct? So 1/3 plus 6 root 5 over 7. What type of number is 1/3?
1/3 is a rational number.
1/3 is rational. How about 6 root 5 over 7?
Irrational.
That's irrational because what does it have?
A root.
Yeah, it has the root of a non-perfect square. So we already know rational plus irrational, what's that going to be? Rational plus irrational. We wrote it down. What does that give me?
Never rational.
Never rational. Okay, but what is he saying? He's saying, oh, the sum must be rational because it is a fraction. Because it is a fraction. Because remember what we said, any number that you can write as a fraction is rational. So let's talk about why that's not really true in this case. Even though when we add these two up, it will end up as a fraction. So if I add 1/3 plus 6 root 5 over 7, okay, then the common denominator is going to be 21. So this is going to be, let's see, 7 over 21 plus 3 times 6 is 18, 18 root 5. Don't worry about what I'm doing, but just watch. So if I get my common denominator and then I add them, I get 7 plus 18 root 5 over 21. Okay, yes, that is a fraction. Technically, that is a fraction. But when I say a rational number, rational numbers must be written as A over B. So when I say a fraction, it has to be a whole number on the numerator and a whole number on the denominator and nothing else. So even though this is a fraction, it is not a rational number. It's still an irrational number. So just to be clear, like just because you can write it in a fraction form doesn't make it a fraction. It's still an irrational number because you can't write it as A over B. So, yep, Jacob is wrong. Jacob is incorrect. Any questions on this one? Okay, moving right along.
Wait, Miss Lopez?
Yeah.
How you got the 18 because since it's not in the root, you had to multiply it.
Yeah, so in order to get my common denominator of 21, I had to multiply the top and the bottom times 3. So I just did 6 times 3 equals 18. But like I said, don't stress out too much about that part. I just wanted to show you guys why the answer is still irrational. Even though it's a fraction, it's still irrational. All right. Okay, I think this is the last one. Maybe I'll do 2 more. So let A represent a non-zero rational number. So just it's not going to be 0. It's anything but not 0. And let B represent an irrational number. So A is rational and B, now we don't know what the numbers actually are, but we just know that A is rational and B is irrational. Which expression could represent a rational number? So let's take a look. So A, negative B. If I have an irrational number and I turn it negative, is it all of a sudden rational or is it still going to be irrational?
It's still gonna be rational.
Yeah. Because think about an example like the square root of 5. If I have the negative square root of 5, well, that doesn't really change anything. It's still an irrational number. So we're looking for which one is rational. It's not going to be A. How about B? What if I add these two together? So A plus B. What type of answer would that give me?
Never rational.
Never rational. So can it be answer choice B?
No.
No. Okay. What about A times B? Okay. A times B. Rational number times an irrational number.
Never rational.
Never rational. So it can't be C either. Let's look at the last one. B to the power of 2. B to the power of 2. When I take something to the second power, what am I doing to that number?
Multiplying it.
Multiplying by what?
Itself.
Itself, right? So B squared is the same as B times B. So that means I have an irrational number times an irrational number. And what do we know about irrational times irrational?
It sometimes equals to rational.
Yeah, sometimes it is. Sometimes it's rational. So which of these could represent an irrational number? D sometimes can. It could. So that's the only one that can, even though it's not always going to be rational, it could be rational. So that's that. So that's kind of how that goes. Like these types of questions really just, it's a matter of remembering the rules and testing each answer choice just to see what you get. Is it going to be rational, never rational, or sometimes rational? So let's do one more. And I want you guys to try this one on your own. So here's my poll. On your own, see if you can figure this one out. Which value is an irrational number? Take about 30 more seconds. By the way, right now there's 3 answer choices that are tied. So let's see which one ends up winning. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Ooh, this was interesting, y'all. Kind of interesting. Let me show you what happened here. So we're not very sure about this topic, are we?
Wait, it
Seems easy.
it was correct. A was correct.
No, this doesn't show you the correct answer. This just shows you what everybody got.
Oh, what? Okay. But what does it mean by red? Red means that it was the highest?
Yeah, so whichever one shows up red was the most popular answer, but B, C, and D were in a complete tie. Okay. See, I thought y'all thought this was easy. It's not. So let's see what's going on here. So we're looking for which one is irrational, first of all. So that's extremely important to realize. Which combination is never rational?
B?
Which, in general, don't look at the answer choices. Just tell me, what types of 2 numbers will never be rational?
5. Square root 5.
Just tell me, what types of numbers? Rationals plus rationals, rational plus irrational, or irrational plus irrational?
Oh,
Which one is never rational?
never rational. I times R and I plus R.
Good. Both of those are never rational. So first off, if the answer is irrational, if it's asking which of these is an irrational number, then you're going to be looking for an answer choice that has a rational number with an irrational number. But now let's take a look at what we have. I'm going to work backwards. I'm going to go from the bottom up. Square root of 3 minus 3 to the power of 1/2. I have a square root and then I have an exponent. I need them both to match. I need them both to match. In order to do the math, they have to match. So can I convert one into a different thing?
Yes.
Okay. How do I rewrite 3 to the power of 1/2?
3 square root.
Square root of 3. What's the square root of 3 minus the square root of 3?
0.
0. What type of number is 0?
Rational.
Rational.
Rational. So it's not D. Not D.
It's
Look at C now. The square root of 3 times the square root of 12. We're multiplying those together, so what can I do?
36 square root.
That's the same thing as the square root of 36. Well, what's the square root of 36?
6.
6.
So I have 6 over 5. What type of number is that?
Rational.
Rational.
It's A because it has a rational and an irrational. See?
Yeah. Well, and now let's look at B. In B, square root of 2 times the square root of 8 is the same as
16.
square root of 16. What's the square root of 16?
4.
4. What type of number is 4?
Rational.
Rational. A is the only one that will be an irrational number, and that's because 4 plus the square root of 7, that's rational, plus irrational, which is always what? Oops.
Irrational.
It's always irrational.
See, I got confused because I thought we were adding them instead of multiplying for some reason.
Okay, so that's something to just keep in mind. If you have something like this, square root of 2 and then the square root of 8, and there's no operation symbol in between them, like there's no plus sign, there's no minus sign, there's no anything, that's multiplication. That's always multiplication. You can think of it like they have parentheses. So you can multiply. So, okay. Questions on this one? I know that there must be questions because only 2 people got it right. Any questions? Okay. All right. Okay, so I'm stuck between 2 options. I'm going to let you guys vote on it. Let me know which option you prefer. So I do have a quiz for you. We can either do the quiz right now and then you'll be done with it and you can move on with your life after this, or we can keep reviewing and then the quiz will be due like as a homework assignment. So tell me in the chat which option you prefer. Do you want to do the quiz now or do you want to do the quiz as a homework assignment? And I'll pick the most popular answer. Only 3 people have voted so far. Okay. Any final votes in 5, 4, 3, 2, 1. So I have 1, 2, 3 votes for, oh my gosh, it's 3 and 3. Okay, so here's what I'll do. I will allow you to start the quiz now, but if you don't finish it by the end of class, because I know that they like to ring that bell way too early at school, then you may complete it after school. So you can start it now. You do not need to finish it right now. You can finish it after school if you do not finish it in this moment. So what I'm going to do is I'm going to post it onto Teams right now. And it always takes like 30 seconds to load up. So just give me a moment. you'll see it come up and you can get started on it right away. By the way, it'll show up on period 2, since that's the class we're in right now. All right, and I'll make it due tomorrow at midnight. I'm being very nice, y'all. All right, I just posted it, but it always takes a moment. So just give it a moment and it should come up soon. Okay, it should have just posted. So go ahead and get started on it. Remember, guys, if you need to review something, you are welcome to use your notes. You can look back at your notes to just check something if you need a review. And you do not need to finish it right now, but now is a good time to just at least start looking at it and get started on it.